Hi everyone, Mrs. Basega here, and today we're learning about how to write a scientific procedure. When I'm looking for a procedure, I want an explanation of all the things you did in your lab to keep your independent variable changing, affecting the dependent variable, and then your control variable is kept consistent throughout. So this is the rubric I use for grading. First, you should be talking about your independent variable and how you change it. So maybe I'm adding mass. Maybe I'm increasing the distance. I also need to talk about what tool is used to measure that variable and how you use that tool. Next, you should be able to identify the dependent variable from your text. Let's say your dependent variable is acceleration. I should see what tool you used to measure the acceleration and how you used that tool. So if you used a motion detector, that should be in your procedure. Finally, I'm looking for a line about how the control variable is kept constant. Maybe you use the same light bulb, or the same Van de Graaff generator, or the same cart every time. But in any case, you should be able to tell clearly from your lab how the control is kept consistent so that you have a fair trial. So this video is going to show us how to write a good procedure, and you're going to see a few examples. Some of them will be using this step-by-step method of writing. Others will use just a whole paragraph explaining those concepts. But in either case, you should be able to tell, based on the description and the procedure, how the experiment was run. So let's see if we can figure out the procedure for this one. This is a procedure a student wrote about changing the radial distance between the light sensor and a light bulb and determining how that affects the light intensity. So let's see what they've got. Radial distance is the independent variable. This sentence makes it clear that we measure distance with a meter stick. We see that the distance changes, and I would give this full credit, all 3 points for independent variable. Notice how it describes how the independent variable was increased, the distance increased, that's how it changes. It's measured with a meter stick, that's the correct tool, and how to use that tool. We measured from the center of the bulb to the light sensor. This group also talked about their dependent variable. The light intensity was measured with a light sensor. They would get both points for dependent variable. They showed that the tool used to measure the dependent variable was the light sensor, and they described how to measure the light intensity. Finally, they used the same light bulb every time. This is the control variable. This student got full credit for their procedure because they accurately described how the independent, dependent, and control work together to make this lab. Notice that they didn't at any point say independent, dependent, control. Instead, they said radial distance, light intensity, and light bulb or light source. They talked about these variables and how they were measured and changed, but didn't have to say independent, dependent, control. Now, this student did the same lab, but I saw there were some flaws in their procedure, and by pointing them out, maybe you can learn to avoid those flaws. So this group got some of the points, right? It says they increased the radial distance. They increased the radius by increasing the distance, right, between the light stick and the light bulb. But what they didn't say is they did not identify the tool, that is the meter stick, that they used to measure the radial distance. So without identifying the tool, I'm not sure what they used. So they increased the radius. I know they measured it in inches, but I don't know what tool they used. So they didn't get all 3 points for the independent variable. For the dependent variable, I can tell that the dependent variable is light intensity. The dependent variable is, in fact, how bright the light bulb was, but that's not how you measure intensity. What I was looking for in order to get this point would be to talk about how they used a light sensor as the tool to measure the light intensity. Finally, for the control variable, they talk about how the bulb was kept at the same brightness. That's an acceptable control variable. So I gave them points for correctly identifying the three variables. I can tell that it's radial distance, light intensity, and light bulb were the three independent dependent control variables, but I don't know how they were measured. As a result, this student got a 3 out of 6 on their procedure. Okay, let's take a look at my next student. They were looking at the rubric and they were using it to help inform their experiment. In their experiment, they changed the amount of mass and they measured it on a scale. They used a sensor cart to measure the acceleration, and they put the cart on the same surface every time. They have almost all the correct things here. I can see the independent variable is mass, the dependent variable is acceleration, and the control variable is the surface. But I didn't give them all the points. Let's rewind. From this sentence, it is not clear what mass they changed. Did they change the mass of the sensor cart? Did they change the mass of a pulley? It's actually unclear. I want you to think of this third point for independent variable, the point that says describe how the independent variable is changed in your experiment. I want you to think of this point as describing how the experiment is run. What I would look for in this one would be they changed the amount of mass on a cart and repeated changing the mass to measure the acceleration. I want some sort of sentence to connect that changing the mass affects the acceleration. To make it better, I would also be really careful about your control variable. A sensor cannot be a control variable. So you can't say things like, we use the same sensor every time. That's not a control. And in this case, the students weren't careful. They put the cart on the same surface every time, but it did not travel at the same speed. In fact, acceleration was your dependent variable. It should have changed when you made things more massive. So the speed can't have been kept constant. That's not a control variable. If they had shortened their sentence and we said that we put the cart on the same surface every time, then they would have got full points for the control. This student did a very similar lab. They were taking mass and using it to pull a pulley that had a cart on the other end. I think this student did a good job about making it clear that they continually added mass to the cart. Unlike the previous student where it was unclear that mass affected acceleration, this one was more clear. We changed the mass and measured the acceleration. This student lost points because they had no control variable. I'm not sure what they're keeping constant in the experiment. In this case, I would have said the total mass of the system is probably the control variable, but they didn't mention it at all. So they lost a point here. So before we look at our last example, let's review what our procedure should have. It should have your independent variable and the tools you use to change and measure it, the dependent variable, which is affected by the independent and how you've measured it, and the control variable. In this last example, students did an experiment where they changed the distance between two charged spheres. The distance was measured by a meter stick, and the force between the two spheres is measured on a scale down here. As the two charges get closer together, the force changes because the closer the two charges are, the bigger the force is. So let's talk about what their procedure should have. So at each point, the red ball changed distance. So they got the point for radial distance measured with a ruler. The force was measured by the scale, so that's their independent and dependent variable. The same silver ball was used for all trials. But the student included an extra thing I want you to be wary of. They started putting their conclusions in this procedure. Their first sentence was, "The force was increased as the ball moved closer." That's a conclusion. That actually doesn't belong in a procedure. I don't want to see any of your results occurring before you conduct the lab. So make sure to leave all of your conclusions out. All right, so best of luck in writing a procedure, and please know you can always ask me for help. If you want me to help edit your procedures or give you feedback, I'd be happy to do so. Best of luck!